Hello, it's Wendy, and this is my video for session 4.1 in the Term 2 Java class. If you're watching this video, I apologize that I'm not able to be with you today. I just had a medical thing, and I forgot to mention it on Friday. But anyways, it's cool. We've got these videos. You can watch them fast, watch them slow, rewatch them as many times as you want, which is always a good thing, maybe. So in the week for Notion material, I've listed some things for review. I'm going to review a couple of these things as we go through the lesson today, particularly about using objects and stuff. And I've got another one of these little there we go, test yourself things. They're very similar to what's in the practice quizzes in Slate. They're just slightly different questions, and it's just PowerPoint slides. And then we're going to jump right into session 4.1. I'm assuming you know, as usual, where to find the material. Make sure also that you've downloaded the demo file for today. I've already got that open. So the demo file for today in the source directory, that's where, pardon me, all the files are that we are going to work with. So method overloading is one of the things we're going to talk about first. Method overloading, we kind of need to discuss this or learn it before we can get into creating our own object-oriented classes. And it's in the topic of methods. We talked about methods before, but it also kind of ties into this object-oriented programming thing. So what method overloading is you might have noticed, and I'll just open up the cat documentation. So this was the documentation for the cat class that we looked at in the previous lesson. And you might recall that the constructor methods, we're going to learn more about constructors today, there's more than one version of the constructor method. And if you go down and look at some of the other methods we might have had time to play with in class, there's multiple versions of the feed method. And this is a common thing in an object-oriented language where you have not just one single method or function, but you might have multiple methods or functions with the same name. And you've worked with methods like this already in Java, maybe without realizing it. So for example, whoops, I'm grabbing my pen tablet thing and it's upside down, which makes a big difference. Let me just put the cursor back in here. Sorry, I'm not going to have time to edit this video, so all my fumbles and mistakes are just going to be, where's my cursor, as is. Make sure I'm on the right monitor here. There we go. I think I got it. There it is. And so when we have methods like, think of println. So you're already familiar with system.out.println. Or print. You can use print also as an example. So you know that if we just do that, println all by itself, it just prints a new line with nothing else. And then there's another version of println where you can give it, there we go, an integer like 5, for example, and it'll print an integer. And then I'm just going to do this. There's another version of println that can take a floating point number like 5.0, for example, and it'll print floating point number. There's another version of println, there we go, that takes a string. So you can do like foo, and it doesn't have to be a string literal necessarily. You can make an expression. So we know from previous experience, this will print foo with a 5 right after it, but it's a string. And so these are not the same method. This is the same println method, it's just different versions. So we have different versions. Whoops, there we go. Different versions of the same method. One version takes nothing, one version takes an integer, one version takes a double, one version takes a string, etc., etc. And so the way we call this is we call this method overloading. So that's what method overloading is. And when you think about how you create methods, which we learned, sorry, I just have to adjust some stuff on my desk to make room. When we learned about method overloading, we learned about how you have a modifier, and then we've only learned static methods so far, so I'll just use static. Although just as a heads up, the println method is not a static method, but it doesn't matter. But let's pretend. So static, and println doesn't return anything. And then if my method was called println, let me just put a little asterisk there. print line, and then you would define a parameter. So what type of parameter would you define here? Would you define no parameter for this version right here? Or would you define an integer parameter for this, or a double parameter for this one, or a string parameter for this one? What data type is this parameter supposed to be? And so this is why we often have method overloading, because then we can have a version that takes no parameters, we can have a version that takes an integer, a version that takes a double, and a version that takes a string. So this is what method overloading is. It's when you have two or more methods in the same class with the same name, but different parameter lists. And in some cases, you can also have a different return type as long as the methods have the same name and different parameter lists. And we're going to look at examples of this so to make it a bit easier to understand. The reason why we have method overloading is it helps with one of the 4 pillars of OOP, which is polymorphism. So having overloaded methods, it makes methods polymorphic. It means that you can have a method like printline and it acts appropriately for strings, for integers, for doubles, etc. That's polymorphism. So let's take a look at overloading. It's kind of hard to see on this computer because my font size is really big, but overloading example 1. And so that's the one I'm going to look at, and I'm just going to collapse this so we have more space. So in overloading example number 1, you'll notice that I've got a nice constant in here, and then I've got a scanner, and then I'm asking the user to enter a type of employee. So I use R for regular or T for temporary. This is how we used to do it old school in the days before graphics, is we would tell the user we expect them, sorry, my computer's really slow and it's just now realizing this is a Java project and it's applying all the extensions, but we'll just go with it. So we would, in a console environment, we would put brackets or square brackets around the letter we wanted someone to type to choose that option. I'm probably repeating myself. I've mentioned this in class. And then what I'm doing is I'm using next to get the first word, because I don't care about the rest that the user typed, converting that word to all uppercase, and then I'm grabbing the character at position 0. So assuming the user reads and follows my instructions, which they don't always do, I'm going to grab either an uppercase R or an uppercase T. And if they type something else, it's okay. So what I did was I have an if statement. If the user typed the letter T, then I'm going to ask for the number of days that they worked, and then I'm going to calculate the pay. But I'm going to assume if the user types something different, I'm going to assume it's a regular employee. And for regular employees, I'm going to ask for the hours worked and the rate of pay, and then I'm going to calculate pay. So what I'm doing is I'm handling 2 different kinds of employees. One type of employee gets paid by the number of days, and the other kind of employee gets paid based on their rate and the hours that they work. But both are using calculate pay. So it looks like I'm calling the same calculate pay method. Here I'm passing it a single double value. I did number of days as a double because someone could work 1.5. So that's why, in case you're curious. So I'm passing it a double for the number of days, but down here I'm using calculate pay, and I'm passing it a double for the number of hours and a double for the rate of pay. So I have a calculate pay with a double and a calculate pay with 2 doubles. So let's scroll down, closing the input stream, printing the result, whoop-de-doo. So let's scroll down a little bit, so around line 47-ish. You'll see these are very basic, simple methods, and it's just here for demonstration purposes. But what I have is I have 2 static methods. They both return a double. They both are called calculate pay. One takes a double argument, and the other one takes 2 double arguments. So all I've done was I've simply just added 2 versions of the same method, and one takes a double and the other one takes 2 doubles. And you can add as many as you want. If I wanted to, let's say I also paid employees based on the department that they're in. So I could do something like public static double, calculate pay, and have a string for department name or code or whatever. And then I'm just going to put return 0 for now, but ideally you would calculate pay, whoopsie, calculate pay based on department, whatever it is, number, name, code, whatever it is, it's a string. So I could do that. I could even, oops, I spelled double wrong up here. Let me just scroll back up and fix that. There we go. So I could even add another version. See if I can get these all to fit on the same screen to make it easier. So I could add another version. Maybe I pay people by department with the number of hours. So I can have one version, calculate pay, and this one takes a string for a department and a double for the number of hours. So I could do something like this. Again, I'm just going to add like an empty return. Calculate pay, whatever. Just because I don't want the errors to distract you. I'm not going to actually code these methods. They're here again for demonstration only. So I can overload calculate pay as many times as I need to for my program to work. But you have to follow certain rules. And of course, one rule is the methods have to all have the same name. In VS Code, if you highlight one, it'll sort of highlight all the matching ones, which is handy because then you can check. If they don't highlight, it means you spelled one wrong. They are case sensitive as well. So they have to have the same name. Otherwise, they're just different methods, right? And then the other thing is the parameter list must be different. And it pays attention only to the number and type of parameters. That's all it's concerned with. So for overloading, let me do this in one of these. This is notes you might want to write down. So for overloading methods, the first thing is name must be the same. Second thing is parameter lists must be different in number and type. And so what that means is that I have one that takes, let me collapse these, one that takes a double, one that takes two doubles, one that takes a string, and one that takes a double and a string. So if I were to create another version, let's say I want to calculate pay, everybody gets the same rate, but it's based on the number of hours. So let's say I go double and then num hours, like that, there. And let me just add a blank return statement in here just to shut it up because I want to show you. Now I have this error here, and it says duplicate method calculate pay double, and it's just saying in this file. So it says you have two methods called calculate pay that accept a double argument. So even though it's talking about this one, obviously, because it's underlined in red. Even though this calculate pay takes the number of days as a double, and this calculate pay takes the number of hours as a double, it doesn't care that I gave the variables different names. It's not interested. It notices, whoops, that they both take a double. And so if I were to, I'll just jot this up here. If I were to call calculate pay and give it 1.5, is that referring to the number of days or the number of hours? Java doesn't know. It's not human. It can't think like we can think. I wouldn't even know. Is that 1.5 days, or they only came in and worked 1.5 hours? Who knows? And so that's why. So that's why you have to make sure that when you overload methods, the number and type of the parameter variables is what matters. They have to be different. So I can't have two methods that both take one double or two strings or one string and one double. They have to be all unique. We call this, the IntelliSense is annoying. We call this the signature. The signature of a method, so different signatures. The signature of a method refers to its modifiers, its return type, its name, and the number and type of its parameters. So the signature has to be different. And as I mentioned before, you can also change the return type, but only if you have rule number 1 and 2 are true. So if you change this one, let's say this one's going to return an int, it wouldn't make sense, but let's just say, for example, if I return an int, this is still an error. You cannot change the return type of the method unless you make sure that your parameter lists are unique, or different. So that's the key thing about overloading methods. So I'm just going to get rid of the one that's an error to make the errors go away. So again, the names of the parameters are not important. It's only concerned with making sure the number and type are different. Obviously, this is an error as well, so I'll get rid of that. And again, I have videos for this with written materials and stuff that you can go over if you need to do it in more detail. I'm just waiting for this error to go away. Oh, I must have accidentally left something in here when I deleted. Yes, I did. There we go. Let's take a look at the second overloading example. So there's overloading example number 2. This is not a practical example. This is a generic example. So this is an interesting one because this introduces you to a common problem that we have when we're overloading methods and we haven't really organized what we're trying to do, what methods we want to overload, etc. So what I've done is I've created 2 integer variables, n1 and n2, and 2 floating point variables, n3 and n4. And I've created, let's just scroll down here, I've created 3 overloaded methods. They're just called method. That may not have been a good idea, but I just called them method. One of them takes 2 integers, one of them takes 2 doubles, and one of them takes an integer and then a double. So we can see we've got these 3 overloaded methods, 2 int, 2 double, and then int and double. And so back up here to line 11, we want to look at each one of these method calls and see if we can figure out what method will execute, and then we can run the program to test our answer. So for this first one, the first one being called is taking n1 and n2 as arguments, and I just added comments here because sometimes in the classroom we're like this and we can't see n1 and n2 up here, so that's why. So n1 and n2 are integers. So when I call method and I pass it an int and an int, we look and see, or the JVM looks to see which method is the best match. So in this case, we have a method or a version of our method that takes an int and an int. So we anticipate that this one is going to call the first method, the one that takes an int and an int. So that's our thing. So we're going to say, okay, this one is going to do int int. So I'll write int like that for the first one. The second one, n3 and n4 are floating points. They're doubles. So we're looking for a version of method that takes a double and a double. So our first one, that takes 2 ints. That's not going to work because you cannot take a double and place it into an int automatically. Or we say implicitly. Doesn't work. But I look at my second one and it takes exactly 2 doubles. It takes a double and a double. So this is the best match for this next example. So this is method double double, just like the coffee. So this next method that takes n3 and n4 is going to call the one that takes 2 doubles. The next 2 are kind of interesting. So this one, n2 is an integer and n4 is a double. So we want to try and find a version of method that is capable or able to accept an int and then a double. So if we look at our first option, we have 2 ints. So we could pass n2 into here, but we cannot pass n4 into the int b. So that's not a match. For the second one, we could pass the int, I'll go back up here, the int n2. That could be passed into the double a because int can be implicitly cast into a double. If you can't remember implicit casting, I think we talked about it back in week 2, maybe a little bit in week 1, but I think it might have been week 2. And so this would work because I can put an int into a double and then n4 is a double, that'll go into a double. So that's a possibility. We may be able to do this one. The second one, this one takes an int and a double. So we can take our int n2 and pass it into A, and our double n4 and pass it into B. So even though both of these technically match, this third one is an exact match. That's what it wants. So it tries to find an exact match first. If not, it'll go with the best one. So this one takes an int and a double. So that's perfect for this method because this method is giving an int or passing an int and a double. Good, so that one was not as hard as we thought. This next one though might be interesting. So this one, n3 is a double, n2 is an int. So we have to find a match that will take a double and then an int. So let's look at our options. So we can't use this one because it's two ints. N3 is our first argument and it's a double. We can't put that into int A. So that's definitely not a match. This one, we have method double A. So N3 is a double, so that matches A. N2 is an int. So that, even though it doesn't match B, it can be implicitly cast into a double. So that one actually matches. It's not an exact match, but it does match. So we'll keep that one in mind. Let's look at the third one. So the third one, our first parameter is an int, but our first argument is a double. So we already know this one will not work because we cannot pass the first double argument into an integer. They won't implicitly cast. The other way around, yes, as we already figured out, but not this one. So the first one and the third one do not match at all. There is no exact match for double and then int, but this one will work. This is the best match. And so this one will invoke the double version. So let's write that in. So method double. So now we can run our program and we can check the output and see if it matched what we thought. We'll go up to the first one. My computer's very, very slow. There we go. So here's our first output. It says I take two integers, so that's the int. So that one was correct. I take two doubles, so that was the second one, double. We established it was going to be double, so that was correct. The next one says I take one int and one double, so that matches what we said. So this one takes an int and a double. And then the last one says I take two doubles. That's the double version. So it actually executed the one that we guessed. So we got them all correct, which is great. One thing that I added here as a comment, and you'll see why if you uncomment it, is this one. I'm passing an int literal and a string. So that's an int and a string. And this gives you an error and it says the method called oops, I can't double click that, can I? I keep forgetting. There we go. The method int in the type overloading example 2 is not applicable to the arguments int and string. So what does that mean in English? So what that means is that it saw you were, oh, stop highlighting, Wendy, because you can't. It saw that you were calling method and passing it int and string. So when it was trying to find the best match, it, for whatever reason, decided that the int version was the closest, and that's the one it said, yeah, that's not going to work. So I don't know why it chooses one, but it does. So it's basically saying that you don't have a version that takes an int and then a string. So the simple way of rewording that error message is there's no match. There is no such method that takes an int and then a string variable. So that's why that one's an error. Same thing with this one. So this one where it just says method 1. So even though we have, it's almost the exact same error message, just the ending. There we go, it says arguments int. So even though we have versions, we have two versions that take an int as the first argument, this one is not passing a second argument. So it doesn't find a version of method that takes an int value. Same thing with this last one. There is no version of our method that takes one double. So remember, it's not just the type, but it's the number as well. So it's trying to match an overloaded method based on the number and type and order of the arguments. So in this case, there are no versions that match these argument lists, which is why I had them commented out, because they're errors. Another thing to note about overloaded methods, if you go down to line 34 and we ask, why is this a problem? So if we uncomment it, we see public static void method int x int y, and the error says duplicate method int in this particular class. So we saw this earlier. So again, this is a problem because the method is accepting two ints. If we were to write it down without the name of the variables, method int, that's the method signature, and that it's a void, but it's public void and it's int. Whereas we actually already have a method int. Again, if you take out the variable names, you have method int. These signatures or partial signatures are exactly the same, which is why this is not acceptable. So when you overload methods, you have to make sure that the number and type of arguments are different. And you also, when you are calling overloaded methods, the way that it matches or tries to find a match, it tries to find an exact match. And if it can't find one, it tries to find the best match based on whether or not an argument can be implicitly cast into a parameter. Let me see. I'm just checking my... Okay. On that note, then, there's one little detail we should talk about. Sorry, my phone is on and it just made a beep. Is if you open up the ambiguous invocation example. So, ambiguous invocation, and it's defined right here if you got your comments open. Mine just collapsed because my extension's taking some time. But ambiguous invocation occurs when you have a method, when you're calling a method, and it either matches more than one or there's no exact match but many like partial matches. That came out really wrong. But anyway, so let's look at an example. So here I have method int a double b, and I have a method double a int b. So this version accepts an int and a double. This version accepts a double and an int. And so if I look at this line of code here, you can uncomment it on line 19. So this method here, when I uncomment it, it says the method int double is ambiguous for the type. And don't worry, but that's just the name of the class again. So what this means in English is the word ambiguous, it's like vague. So if you don't know vague means if I said I have an animal, that's really vague. Like, what kind of animal? So vague is the opposite of specific. So ambiguous kind of means the same thing. So in this case, ambiguous can mean there's no specific match, right? It says there's more than one. So in this case, ambiguous invocation, whoops, there we go. There's more than one match. I don't know which one you want. So like, I have an animal. I don't know which animal you have. Right? Draw my animal. I don't know what animal you have. What does it look like? Same thing. Call this method that takes two ints. Huh? Which one? Why is there two matches? So let me try and get this all to show up together because it's easier. You know what? I'll just collapse this. So when I call method with two ints, so two int literals, and it says, okay, an int and an int. So it checks both. It says this one takes an int and a double. This one takes a double and an int. Neither one are an exact match. So let's see if we can find the best match. So an int and a double. So our first one, well, an int 1 can go into the int a, so that's okay. And then the int argument 2, that can be implicitly cast into a double. So check, that one matches. Check, like check mark, correct. That one can match. This one, so we've got a double. Well, the int 1 argument can implicitly cast into a double. And then our int 2 argument can go directly into B with no problems because it's an int. So this is also a match. So even though neither is an exact match, they both are good matches. And so how do we know which one? Which one is the best? Because they both match. And so Java doesn't know either. So that's why it's telling you it's an error. It's saying that it's ambiguous. I don't know which one you want. Both of these are matches. So which one do you want me to execute? And so you can't run this program because it's not going to work. It won't let us compile. And so that's something you want to be careful of, is ambiguous invocation. So now that you kind of know the syntax and the basics of overloading, before we start writing our own, open up this little overloading exercise. So in this exercise, what I did was I gave you 4 different versions of print things. So this one takes 2 strings, this one takes an int and a double, this one takes 2 ints, and this one takes a string and a double. So looking at each one just prints out its arguments, that's all. And so looking at the different versions, I labeled them version 1, version 2, version 3, version 4. I want you to have a look at each of these 4 statements and don't run it yet. See if you can figure out which one executes version 1, version 2, version 3, or version 4 for each calling statement. And then once you have that done, then you can run it and check your answer to see if you're correct. And then when that's done, you can answer this question: what is the problem with print things 1.0, 1.5? So go ahead and pause this video, give that exercise a try, and then resume the video once you're done. Okay, hopefully you actually paused the video and tried the exercise, and I'll go over this really quickly, and then we're going to get into the next video, which is on coding classes. So first, we want to look at each one of these method calls and figure out which version of each method executes. So here we have a version that takes two strings. So let's see if we have an exact match. And if we look through all of the different signatures, we can see, we have one that takes two strings. So let's go with version 1 for this one. So I'll just put a 1 there for version 1. Now the next one, this one takes a string, and that's an integer literal. So an integer and a string. So do we have an exact match? Integer double, integer integer, string double. So if we look at, I said integer and string. Sorry, I said I wasn't going to edit this video. Sorry, I'm looking right at it. String and integer. Sorry, I was like, wait, where is the right match? Let me start over. So we're looking for a string and an integer. So string, string, int double, int, and then, int or string double. So now we're looking going, we don't have an exact match where it's string first and integer second. The only ones that have string first are string, string. And we can't use that one because you can't sorry, I'm scrolling up and down. We can't take this integer 1 and put that in a string. That's not going to work. These two don't work because the first argument is an integer. This one, we have one that takes a string, and then the second argument is a double. We know we can take an int and implicitly cast it into a double, no problem at all. So this looks like, even though it's not an exact match, it's the best match. That's version 4. So I'll add a little 4 here. And for this next one, I'm going to pay attention. So now I have an int literal and another int literal. So let's scroll down and see if we can find an exact match. So it's not going to be the string ones. Int double. Here we have an exact match. Int. So 2 ints, 2 ints. So int, that's version number 3. So this one, int, or 2 ints, is going to be version 3. And then this one, an int, and then this is a floating point literal, so that would be a double in Java. So int and then double. So we can skip over the ones that start with string. There we go. We have an exact match right here, version 2, an int and then a double. So we didn't have to search for a best match for that one. We found an exact match. The only one that didn't have a best match, that was it too. The only one that didn't have a best match was this one, but we were able to find a good match, and that was with the string double version. So now we can check. So 1, 4, 3, 2. So we can check and see which one executed. So we've got the one that prints 2 strings. If any of these were incorrect, then we would have gotten an error. But so hello world, that's the hello and world. And then you can tell this one is executing the string and then the floating point number, because that was this one. So the one that was not ambiguous, the one that didn't have a perfect match, that was number 4. So hello and then integer. The way that you can tell that it executed the right one is because I formatted the double value, and that's clearly a formatted double value right there. So it executed the string in the double version. Similarly, we can check and make sure that this one executed version 3, because you can see that they're just plain ints with no formatting. They're obviously not strings, and they're obviously not floating points or doubles, because if they were, they would have had the decimals after them. So that obviously executed the int version because it printed them as 2 integers. And the last one was an integer literal and a double literal. So that would be, which one was int and double? That was version 2. So formatted as an int and it formatted as a double. See, that output matches the formatting. And so that was version 2. That was this one right here. So we got them all correct. Hooray. And then this one, what is the problem with this one? So if we do print things and then 1.0 and 1.5, again, it says in the error, the method print things in double in this class is not applicable for double. So no match. So this one has no match. If we look through, we don't have an exact match for a double, and we don't even have a best match. Obviously, we can eliminate the string versions, but neither of these are a good match because the first argument is a floating point or a double number, and they can't be implicitly cast into an int. You can put an int into a double, but you cannot put a double into an int, or vice versa. Again, you can go back to, I think it was week 2, if we need to review implicit casting. So that is the problem with the last one. There is no match for that one. How would you solve that in real life? Then you would either figure out maybe there's something wrong with the arguments you're passing, or you would create another version of your overloaded methods. Cool? Cool. All right. So in terms of coding overloaded methods, we're going to do that in the next video when we talk about creating classes. So I'm going to end this video here because it's easier to upload smaller videos than to upload larger videos. And I will see you over in the next video on creating classes. Some idiot with their car engine outside.